Okay everyone, I'm going to do example B in the book, and I'm going to try and do it freestyle. I will try to not follow the book as I do it, as if I was doing it as a problem in an exam or something along those lines. So I'll just write out the initial problem. I'm also needs to make the caveat that my convention will not necessarily be the same as the book. So for example, I might be resolving forces in the y direction first, where the book doesn't. I might name my forces along the beams along the members slightly differently. So that's not wrong or right. And I might define directions pointing opposite direction, which you might think they should be. So I might decide to define pointing downwards as a positive, for instance. Okay, I'm going to try doing this on OneNote. Let's see how it goes. So let's first sketch out the problem that we're looking at. Thank you, and you're installing something for me. We haven't actually been given the geometry, I think, for this problem. Doesn't really matter because all we're interested in is angles. So these could be 2 meters long or whatever. So I'm going to work in kilonewtons. They've already worked out the hinge values for me, the reaction support values. They've got this weird labeling for the letters. So we have an A, G, F, and an E, and then we've got B, C, and a D. How do I select pen colors? Interesting. I've been asked to find GC, which I'm going to call CG. I like calling my using the low letter first. So we're asked to find that. Okay, I'll follow their convention. So they want to call this GC. We want to find this, the internal forces here. So the GC. We want to find BC. So that's going to be this one here. Find the internal force there, and find the internal force GF, which is going to be this one here. So normally I would tackle this problem using method of sections, because I can cut through the framework in one go, and I would only have 3 equations to solve. Using method of joints, however, this is going to take a while. So this is GF. Okay. So with method of joints, you have only 2 options where you can start, because you can only cut through 2 members. So that means I can either cut through here, or I can cut through here. Okay. Getting these values, it looks vaguely that it's easier to start with A, which is what they do in the book anyhow. So that's all good stuff. So now let's hide the book and see where we get to. So I can now see where my picture is. Make myself a little bit smaller. Okay. So, I'm also going to do it how I do it in an exam, where I wouldn't do this step of breaking down the force when it's in the skewed direction. I would just use one free body diagram. You tend to do too many diagrams. So you kind of get my approach on how you would tackle this problem. So where's my fin black gone? Black thick, black fin. So I'm going to do method of joints at A. So I need to do a free body diagram as if I cut round that joint, and we've cut through the members, and we've exposed the internal forces that are going on inside those members. And we're going to give them a name. So I'm going to call this AG. I'm going to call this AB. And the other thing is I need to keep any forces that are acting on that joint, and there's a 60 acting on that joint. For this diagram, it's a bit plain, so I will use any geometry that whoops, that's not 30, that's 60. I will use any geometry that I found from my original framework, and then I'll start putting it on this free body diagram here. Okay, so I've got 60, and to get to the vertical, I need to swing through 30 degrees. Okay, I like using cos thetas all the time. So I'm not going to do what's in the textbook, because I know I've had a look. I'm going to resolve in the y direction, because that will pick out only AB, and we'll define upwards, positive, as going upwards. So let's apply this equation. So that gives me AB. Swing through 30 degrees, that means we're going to put that into cos. And then we've got 60 going upwards. Whoops, let's keep it all here. 60 going upwards. Okay, from there, let's rearrange this. AB equals minus 60 divided by cos 30. Now this is the point where it's only in an exam situation. I would advise don't be a hero and try to remember whether cos 60 is root 3 divided by 2 or not. You put it in your calculator. So minus 60. Whoop. We've still got minus 60. Minus 60 times divide by cos 30. Okay, you see that? So that is minus 40 root 3. Let's write this out in real money. Do that by pressing the SD button, and we get minus 69,282. Use 5 sig fig if you're doing real numbers. So I'm going to tell you it's in kilonewtons, and I'm going to tell you that's in compression because I've got a minus sign. So minus means it's always in compression. Okay, so that's found my AB there. Now let's resolve forces in the x direction. Okay, and find out what AG is. So we've got AG going in this direction, and then we need to swing AB through 60 degrees to point it left to right. and I can't see any other forces going left or right, so that's the job done. Equals 0. I want to know what AG is, so AG equals minus AB cos 60. Well, AB is minus 69.282. Actually, I should be using minus minus 40 times root 3 cos 60. So let's go back and actually use that value. So we got 40 root 3 times by cos 60. Okay, you see, not quite what I've written down on the page there. I've gone back and used the irrational number. So that gives me 20 root 3. And then I'll write out, press the SD button, write it out, so it becomes 34.641 kilonewtons, and that's in tension. Okay. Right, so that's joint A done. So now let's go to our joint B. So I could either go to, I really want to get to the joint G to pick up these forces here, don't I? But the problem is if I go to joint G now, this isn't known, this isn't known, and this isn't known. So I'd have 3 unknowns. So I need to go to B to pick up. All I'm interested in actually when I get to B is BG. So I can get to this joint here. Actually, and I've been asked to find BC anyhow. So we need to find BC anyhow. So the next joint we're going to go to is the B one. So let's do a little sketch of that. Okay, had a break. I'm picking it up from joint B, hopefully. Right, so let's have a look at joint B. So joint B is up here, 60 degrees, and another 60 degrees on that side there. So what these forces are going to be called? So this one will be AB, BG, and BC. Cool. Always good to label this up that you're doing method of joints and you're at B. And might want to put a little bit of additional geometric information there. So if I resolve down, I need to swing through 30 degrees. So I'm not going to split up my components. That's going to take pages and pages of work. Okay, so I'm doing it quicker than what's in the notes. So also different to the notes, I'm going to be resolving down first. The reason is because I know what AB is, and these are going to be my 2 unknowns. So if I resolve downwards, I'm only going to pick up the unknown BG. Notice I've decided to resolve downwards as positive, and that's a good idea, because in my view anyway. Again, the book wouldn't follow that convention, because if I say downwards is positive, then I can just visualize this a lot easier. I just want to swing this vector through 30 degrees, and then it's pointing downwards, and it's a positive. So we need to just do then BG cos 30. AB, we need to swing that through 30, and then it'll be pointing downwards. And there's nothing else there. So that's actually going to be easy, because these cos 30s are going to cancel. So the unknown BG, that's right, and there's nothing else there. Yeah, there's nothing else there. So this BG is going to become minus AB. Where's AB? Well, it's either this value or that value. So that was minus, so it's either going to be 40, let's write in the irrational value, and then underneath write in the real money. And that's going to be intention. Okay, cool. So now let's have a look at resolving forces, and we're now going to resolve forces in the x direction and find out what BC is. So resolving the x direction, for that I'm going to need some bit more geometry information. How many degrees does it take for me to swing my AB to hit the horizontal? Well, the acute angle here is this 60, so I can swing it through, it will hit 60, and it'll be pointing the wrong way in terms of my arrow here. I want to go left to right. So I need to swing AB through 60 degrees, and it ends up pointing the wrong way, so it's minus. Alrighty. This force here, I need to swing that through 60 degrees, and it'll be pointing the right way. And then finally we got BC pointing left to right. Okay, let's look back and substitute our values in. So BG, we'll substitute in the, not the final one, but the one before. And that's times by cos 60, which is going to be half. Put that in your calculator if you don't believe me. And then the AB minus 40 root 3 minus, this is why it's good to use brackets, so minus 40 root 3 times by half plus BC minus, well, two halves make a whole, so that's going to be that's positive, so that'd be a minus. Okay, 40 root 3, I've seen previously, is a minus 69.282, which will be in compression. Okie dokie. Right, what else do I need to do? So I've now done the B joint. I found the BC, that's my first one on my list. Finally, I can now move to the G joint. Okay, and I'm fairly sure. I'm tempted to refer back to notes to double check whether this is GC or GF. I think I will do. You'll only complain if I get it wrong. So, what have they called it? They've called it GC. Yeah, okay. Let's go to the final joint then. So the final joint is this one here. Move those things. So we got 60, 60, 60. So you got AG, go in that direction. We've got BG, going off in that direction. We've got GC going off in this direction here. See where I am. GC. We got GF going off in this direction here. Gonna split this down the middle, 30 degrees, 30 degrees, 60 degrees, 60 degrees. Okie dokie. So we know what AG is, we know what BG is. Again, seems sensible to resolve in the Y direction first and find GC. This time we want to go upwards, things are pointing vaguely upwards. So I've got BG swing through cos 30. I've got GC swing through cos 30. And I reckon I've forgotten something. I think I've forgotten a load. Yeah, so at that point there, we've got this load. It's horrible. So we've got this load here. Okay, so we need to add this to our free body diagram. So that's going to be minus 90. And so that's going to give me GC cos 30 equals 90. Take away BG cos 30 degrees. Okay. 90. What is BG? I can see that is 40 root 3. What's cos 30? Well, cos 30 is going to be root 3 divided by 2. So that's going to end up as 90. Take away 20 times 3, which is 60. So that's going to give me 30. Okay. I've been a bit naughty here. So GC cos 30 equals this. GC cos 30 equals this. Next, what is cos 30? Cos 30 is root 3 divided by 2. Right, so that makes my 10 divided by root 3, and then that's going to be times by 2. Okay, so what I've done there is I've taken the 3 out of my 30 and I've divided it by a root 3. It leaves me with a root 3 on top, and because it's divided by 2 on this side, it becomes times by 2 on this side. Does that make sense? Probably not. 20 root 3. Don't know if I got any 20 root 3s previously. Yeah, one up there. 34.641. And that is obviously intention. Okay, yeah, I'm expecting that to be intention, I think. Weight's pulling it down. Now for the GEF, which again should be intention. I would have thought. So we are going to now resolve in the extraction. So that gives me minus AG minus BG cos 60 plus GC cos 60 plus GF, which is what we're looking for, 0. So we've got GF equals AG plus BG cos 60. Take away GC cos 60. Now let's substitute in our values. So for an AG is what? Go all the way back to the beginning. That is a 20 root 3. What is a GC? BG, sorry. What is a BG? It's Saturday night. No, what's the song? Bee Gees. Tell me a Bee Gees song. Staying alive, staying alive. Staying alive. BG, anyway. BG, you are 40 root 3. And then we got a cos 60 there. So a cos 60 is a half. Minus GC. Oh, whoops, I'm going to substitute my GC value in. So GC is 20 root 3 times by a half. If that's all correct, I will be amazed. So we've got 20 root 3 plus another 20 root 3, take away 10 root 3. So I make that to be 30 root 3 overall. I definitely never had one of them before. So 30 times root 3 is 51,961,962, sorry, kilonewtons in tension. What's the book say? I've only got it right. So I'm going to mark myself and give myself 10 points out of 10. I will use a thick red line. No, that's green. That's what modern teachers marking. I'm old school. Thick red. Okay, so you should have, young man, where have you gone? Where's the answer gone? Huh? You've disappeared on me. It's because I haven't plugged you in. Right, what are we looking for? Here we go. Let's do some marking. So GF should be 51.96 in tension. Yes. GC should be 34.64 in tension. Yes. God, they did pages and pages for G. Okay, BC, you should be minus 69.28 in compression. Yes. BG. BGs. The BGs, you should be 69.28 in tension, and that is a correct. AG. AGG, which is a horse. AG, you should be 34.64 in tension. That is correct. And AB, you should be minus 69.28 in compression. That is correct. You have got 10 out of 10. You go top of the class. Well done. Smiley face with curly hair and glasses.